Honors Algebra 2, Chapter 13, Section 4. So we're going to be evaluating inverse trig functions and then solving for angles. So inverse trig functions, when we're dealing with inverses, we actually have to restrict the domain to keep it a function. And we'll see more about this in Chapter 14 when we start graphing, but if you look at these three functions, the sine, and you look what the sine is on the unit circle, the sine is our y value. So our y value here was 1/2, and then it's square root of 2 over 2, square root of 3 over 2, and then we get a y value of 1. And then it starts repeating these, which would make it not a function. And so we can't let it go into that second quadrant. But we could have these negative y values as well. So we restrict it to this portion of the unit circle, which means our x values, or our theta value here, is from negative pi halves to pi halves. So we're restricting the domain for the sine from negative pi halves to pi halves for sine. For cosines, the x values, so our x values is anywhere from 1 all the way to -1. So we're going to go from 0 to pi. So for cosine, we're restricting theta from 0 to pi. That way it stays a function. And then tangent is similar to sine. We're restricted from negative pi halves to pi halves. So when we're asked to find the inverse function for sine, cosine, tangent, we only are looking for the angles, the theta values between these two values. So here's an example where we're asked to find the inverse function of cosine. So cosine -1 is the inverse function of square root of 3 over 2. Typical way to write it, we write cosine of theta equals root 3 over 2. When we're writing the inverse function, we're actually writing to solve for our theta value. And so cosine of theta is equal to the square root of 3 over 2. So this inverse function is saying that this is our ratio. What is the theta value that gives us this ratio? So in the unit circle, I know square root of 3 over 2 is my x value for cosine. So I know that this is going to be square root of 3 over 2, my x value is. And so where does that happen on the unit circle? That happens if we have the 30, 60, 90 triangle, or this is going to be our 30-degree angle, or our pi 6. So then I know that cosine of, inverse cosine of root 3 over 2 is going to be pi 6. For the inverse sine of 2, we can also write that as the sine of theta equals 2 is what's trying to ask us. And so where is the sine value, the y value, going to be 2? Well, on a unit circle, sine is the y value. So this y value here is 1. Sine is never going to be 2. So for this, there is no solution. Sine is only between -1 and 1. So new cosine. Cosine can only be between -1 and 1. Anything on the unit circle, our y values here can only be between -1 and 1. For cosine, cosines will only be between -1 and 1 are x values. So you have kind of a range of possible numbers for that. When I'm solving these problems, they're a little different. They're not asking us to find the inverse function because it has like the sine of -1. They want to know what theta is to make this true or to solve it. We are given some angle measures to know that we're between 180 and 270 degrees. We can just punch this in the calculator using the inverse function, like the sine of -1 of -5/8 in the calculator. And it will actually find our measure. I'm making sure I'm in degree mode because I'm giving it to us in degrees. If I do that, I'll get -36.68 degrees. And so if I look at the unit circle, or at the graph here, -36.68 is right here. So that would be like this triangle. That's one triangle that gives us a ratio of -5/8. So it'd be like -5/8. But there's another one that this occurs in, because I don't want this angle right here. I want it between 180 and 270. So then I can draw a second kind of triangle. Where else is sine negative? So it's all students take calc. So sine is also negative in the third quadrant. If I draw the mirror image of this triangle, I get the same triangle here, -5/8, which is the same ratio. And this angle here, what is this angle? And really, theta is this angle. So if I first find the reflection, this angle is still going to be like a 36.68 reference angle. So it's going to be 180 plus the 36.68. So if I add those, 180 plus 36.68, I find a theta value of 216.68 degrees. So this would be the angle they're asking for between these 2 degrees that makes this equation true. Cosine of theta equaling 0.4. Well, sometimes I change that into fractions because I want to see if it's on the unit circle. So 0.4 is like 4/10 or 2/5. Okay, so it's not one we know. It's not the square root of 2/2 or 1/2 or something like that. So it's not on the unit circle. But I do have to check. And so again, I can just plug this in the calculator as the inverse of 2/5. Inverse cosine of 2/5. If I do that, I get 66.42. And so where's 66.42? That's going to be up here. 66.42 is that triangle. But what angle do I want? I want the angle between 273.60. So I want the angle in the fourth quadrant. So I can make a mirror image or reflection. If you think about all students take calc, cosine is still positive there, so it works. So I'd have this angle, which would be like -66.42, or the theta value they're looking for is in the positive direction all the way around. So it's 66.42 shy of 360. So I can do 360 minus the 66.42. You get a value of 293.58 degrees. The last one, tangent theta equals 2.1. So we can do the inverse tangent of 2.1 in degree mode, and it finds a theta value of 64.54 degrees. And so that's similar to the previous problem, about there, which is a triangle. So all students take calc. It's positive there, but where else is tangent positive? It's also positive in the third quadrant. So we're going to have this triangle. So this angle here is also going to be 64.54. So it's going to be 180 plus the 64.54. And so we get 244.54 degrees is the theta value they're looking for. So notice that there's 2 spots of every unit circle that would make this true. For these 3 problems, they're restricting it to only one of those values. If I don't restrict it, you need to give me both angles as possible solutions. So what is the measure of the angle theta in the triangle shown? So if we want to find that, we're given 6 and 11 are 2 of the sides. So it goes back to kind of what you're doing at the beginning of the chapter. Choose an angle, label the side, so this is adjacent and hypotenuse. So I can write that cosine is the trig function that uses adjacent hypotenuse. So cosine of theta is going to equal 6 over 11. And I can do the inverse cosine of 6/11. Plug that in the calculator. I get 56.94. So C would be the correct answer there. And here a monster truck drives up a ramp in order to jump onto a row of cars. The ramp has to be 8 feet, height of 8 feet, and a horizontal length of 20 feet. So now here's a question. Horizontal, so it's going to be this distance, 20 feet. What is the angle of the ramp from the ground? And so again, this is our angle. So we're doing with opposite and adjacent, so we tangent. Tangent of theta equals 8/20. And so then I can punch that in, the inverse tangent. 8 divided by 20. You get 21.8 degrees. So that would be the angle to give us this ramp. So we're going to call it good for the night, and we'll see you tomorrow.